Good day, everyone, or good afternoon, or good morning. My name is Kumo, and I'm a course advisor for ECT. Thank you for joining us for today's webinar. And today's webinar will be presented by our program leader, Dr. Shaalan. And before we get started, maybe you guys could just let us know in the chat box where you are attending from. And I'd like to bring your attention to the notification as well as the chat function. So if you can just switch off your notifications, that's just to minimize any disruptions that may occur during the presentation. And we do have a Q&A function, so you can pose your questions to Dr. Shaalan as the presentation is going, and he will address your questions closer to the end of the presentation. So if you do not have the chat box, the Q&A function, you can always put your questions in the chat box. And for today's webinar, there will be a certificate of attendance, which will be sent to you within 4 days from today's presentation, and the copy of the slides, as well as a recording of this presentation, will be sent to you within 2 business days to your email. So at the end of the presentation, I will provide you with the QR code and the link for a form that you need to fill out. And that's just to ensure that we've got the right information so we can send your presentation as well as the certificate of attendance to the correct email. So with that being said, just note that it will take 48 hours before the link for the QR code expires for the certificate of attendance and the slides. And for those of you who do not know about ECT, I would just like to give you some information with regards to ECT and what we're all about. So we are an engineering specialist institution, and all our programs are industry-driven programs, and we offer world-class accredited education, and that's all thanks to our lecturers and instructors, as well as our unique delivery model. So for today's event, I would just like you to follow my instructions. So we run a smooth presentation, and Dr. Shaalan will be taking you through today's topic, which is the 7 wastes, hidden costs that erode manufacturing performance. If you don't mind, Dr. Shaalan, you may take it away.
Thank you very much, Como. I think I took the lead now. So hello, everyone. Nice to meet you all. Thank you all for attending and sparing the time to be part of this series of webinars. It's always appreciated that you are sparing some time to learn more and to trust us with your time to join us and to learn something from us. So, as Como said, today's is going to be on manufacturing, and it is going to be on lean in general within the manufacturing industry. Lean in general, it's a big topic. We're not going to touch everything in it. We're just going to have a glimpse into some stuff that I experienced, a lot of companies are experiencing with their day-to-day operations and how they are doing things. So before we start, I would like to give you a little bit about myself. So my name is Abdu Shaalan. I am the program leader for industrial automation programs, undergraduate and postgraduate at the ACT. I take care of the programs, make sure the programs are up to standards, the students are getting what they should be getting, and getting the knowledge and experience that they need. So, 2 seconds. Okay, nice to meet you guys. So, yeah, it's good to see everyone here from different countries. Amazing, even from the UK as well. So that's always a good thing, and really appreciate the time that you've been giving us or trusted us with to attend this webinar. So I was saying I'm taking care of the programs, making sure the programs are up to standards. I'm competing with high-end universities within the UK, and with our unique model of being fully online, it is not as easy, and we always try to make things approachable, understandable, easier for everyone, and to accommodate everyone's criteria, conditions, life circumstances. If you have a family, if you have a job, if you have whatever commitments, if you are a carer, all of these different commitments we are focused on, and we always try to accommodate them. So for today's agenda, we are going to cover two main things. We are going to look into what are the types of activities that we are dealing with, and we are going to have a slight touch on the 7 deadly wastes. So to start with, and to have a look and start to talk about what are the different activities that you might have within a manufacturing setup. So in general, when you are talking about a manufacturing environment, you are talking about, well, what am I doing there? So what you are doing there, you are trying to transform some sort of materials from one shape to another. And based on that transformation, you are making a profit, you are making a living. And that's the whole idea, really. But with this, you start to get into different types of activities that you come across. And these activities can be split into 3 main types. First type is value-added activities. When we talk about value-added activities, we are talking about things you as a customer are willing to pay for. So for example, if you want to go and buy a table, so what this carpenter or this wood manufacturer is doing, well, they are buying the raw wood, logs, for example, and they are doing all of these different processing, treatments, cutting, shaping, gluing, nailing, all of these different processes to make you a table. So it's a transformation process from being a raw material and all of these different processes in between in order to make it a finalized, useful product that you have or you want to pay for. So this is one of the things. So when you talk about a value added, this is activity. These are activities that the customers are willing to pay for. Well, you did transform that piece of wood from being a log into being a table. It is a physical change that takes place on that product. It is a successful application from the first time, meaning that, well, I bought it, it is working from the first time, there is nothing wrong with it, I don't have to go back with it and amend it or go through any warranty or any return or any fixations or whatever. It is doing what it should be doing from the first time. And you as a manufacturer, from the first time, you managed to produce a fully functioning table. You didn't have to go back again and do some rework in order to improve it or to fix some issues that happened to it. So this is the value-added activities. It is something that you do that adds value to that raw material and the customer is willing to pay for. And then you have the essential non-value added activities. So these are the things that you as a manufacturer, well, you have to do them, but the customers, or it is not adding any value to the product that you are dealing with. And this can be reflected, for example, as, well, advertisements, incentives to the people that are working. If you want to buy a radio for the people to listen to music while they're working. So these are things that you are doing and you have to do, but it doesn't add any values. You can add to this all the other things as well, maybe the bills, maybe all the different things, bills, rent, taxes, all of these are essential, but they don't add any value to your product. And this is the key when you start to look into what makes a product or similar products have varying prices. It's because different manufacturers manage to excel in how they remove all of these different wastes or all of the things that are not needed within the process. And this takes us to that third point, and this is the waste. The waste are things or activities that do not add any values to the products, and the customers are not willing to pay for them, and they are not essentials. So it is just a pure waste of different things that are not really needed at all. But you as a manufacturer, you are paying for it and you are enduring the cost for it. And this is when you start to look into similar products with the same quality, but very varying prices, because one managed to reduce all the different wastes and the other did not. And this is what we are going to have a slight touch on today. We are going to discuss it slightly and to find out what could be the different types of wastes that might exist within the manufacturing industry. So a little bit of representation of all of these different activities. So looking at the top here, let me get the pen. So what you're dealing with here, you are dealing with the total lead time through the value stream. So all of the time that is allowed in order to make one product. And with this, you start to have classifications. So you have the wastes and the non-value added activities. And then you have the value added activities, which is usually a smaller portion actually of the whole thing. Then you start to look into, well, I need to reduce my cost. I need to improve what I'm doing in order to be able to compete in the market. So some people would say, well, I have 2 or 3 quality checks or quality control points within my manufacturing process between the different activities. I'm going to cut this quality control checks from 4, for example, to 2. And by this, I am reducing the costs. I'm reducing the overall cost in general. And this is the biggest mistake. So people start to look into this area and start to cut what actually the customer is looking for. Because when you have these different quality checks, or you have extra treatments, or the use of better material, this is impacting the quality of the product. And they leave that waste and non-value added activities untouched. And that's always the wrong approach. The right approach is to look into what are the wastes and what are the non-value added activities that you can tackle. With this, you are leaving the value added activities, the things that makes you money as is. Customers are happy with it. Everything is how it should. You want to reduce costs, look into what you're wasting your resources at. And that is always the right and the correct approach for how you should be doing things. So when you are looking into the wastes, what are the different wastes that might exist? It all came from Japan, and the Japanese came up with 7 deadly wastes. And these 7 deadly wastes are classified into inventory wastes, waiting waste, defect waste, overproduction waste, motion waste, transportation waste, and over-processing wastes. It has been highlighted and indicated that all of these 7 sources of wastes are the major sources of waste that, and the major and the main sources of waste that might exist within any manufacturing environment. So, starting with the waste of defects. So, if you are making a product and that product came out with certain defects, like how we can see here, this is a pair of shoes, and one of the shoes has the logo upside down. So this is a defected product, and that defected products cannot really be sold to the customers, or if it got sold, it is going to be sold with very reduced price as a scrap or as a defected product. So you as a customer, you are not willing to pay the full price for it, and you are not, and the company as a manufacturer is not going to make their money back even on it, and it is going to be very good even if they just made their money back on it. So there is no profit at all on it, and highly expected that it is a loss. So when you look into that defect, you start to look into different examples like the rework. I started to have to push that pair of shoes back into the production line to fix it. I have to, at certain cases, to scrap it, so it's not fixable. For example, like how it is with injection molding applications or products. Well, it is a part that has been made, it is defected, you can't really fix it. Maybe it came out with distorted colors, maybe it came out with wrong setup, whatever it is, but or brittle, and it is breaking down. So all of these are defective products. You can't really do anything with them rather than you just have to scrap it. Maybe you're getting a missing part with that product, so it is not fully assembled. I saw years back a video for an automotive manufacturer manager from a company, and he was saying that, well, one of the cars came out without an engine at a certain point. So this is the sort of defects that happens, and in order to fix it, that is going to be much higher cost impact on the company to fix it and to make it right. Maybe you are using the wrong parts for that product. So again, that's a defect because it's not working how it should, and it is not going to work how it should with using the wrong parts. Incomplete documentations as well. So you might have a product and that product is good, but you don't have any sufficient documentations to tell you how to operate it, how to maintain it, how to commission it. All of these are incomplete documentations. I got involved with one of these things, or through my work over the years with one of the companies. We were adding, or we were modernizing one of the machines, and we got a control system. And that control system was amazing. Throughout the whole development, the company was in contact. They were showing us what they are doing. Everything was okay. Everything was amazing until they delivered the control system. And there was literally down to no documentations to tell us how to connect it, how to commission it, how to maintain it, anything about it. So there were no documentations, and we couldn't really deal with it correctly. And we had to be back and forth with the company to get the correct documentations or to get something that we can work with. And that's a big issue that we deal with. So incomplete documents, this can be classified as a defect because it is still it is a barrier that is not allowing you to use the product how it should. It is always said that it is hard to measure the waste of defect. As we said, you have many different sources of defects. It can be back to whatever the reasons, but you can measure its impact. So you can measure its impact by a few things. So you can look into the warranty cost. So how many customers came back with a warranty claim? So they sent you back the product for fixations or for refund or for replacement or whatever it is. The rework cost, how much did it cost you to fix these parts or to fix that mistake that happened in that product? The field service repairs. So when you send someone out to fix something that went wrong with one of your products, again, this is a bill that you have to look into. The loss of customers. So you started to have decreasing number of customers coming back to you or approaching your products. You have a lot of products now on the shelves and no one wants them because customers started to lose faith in your products. And this is when you look at any product and you say, oh, well, this is a bad company, I'm not going to touch it. And that's the whole idea. Start to look into this and you start to calculate or look into what are the costs that I am enduring because of the defects. And it can be back to any of these four elements, whether it is a warranty, a rework, field service, or losing an entire customer. So within the manufacturing sector, it is always said or estimated that if you have a production line and that production line, you are making, as we said, a table. So if you're making a table, so you're cutting the table, first you're cutting the wood, and then treating the wood, maybe painting it, and then putting it together, adding some extra features to it, whatever it is. So these are different processes that goes one after another. And it is estimated that each time a defect passed from one stage to the following stage, it costs 10 times to fix it if it was code from the start. So it's a big impact and it's not that easy. Came across this many times before with the automotive industry, for example, where they had an issue with the painting or with the paint chamber. So this is where we have the chassis and they started to paint it, comes out already done, and then start the assembly process. So there was an issue with the temperature and humidity of that painting booth or chamber, and because of this, certain cars or number of cars came out with rainbow colors. So the colors were not consistent, it was messed up, it was not correct. And that was found out very much later on in the inspection of the final product after everything got assembled. So this car has to go back again and has to be repainted and had to be wrapped, and all of the process, like how you can see when you fix it, you fix your car or take it back to the body shop. It's not an easy job. So it costs a lot, and it's not just an easy fix in order to catch it or to fix it or rectify it how you would think. So what could be the causes of defect? So lack in process checks. So you don't have any technology, let's say sensors that can check on the product. You don't have any quality checks within the process to make sure that, well, it passes the quality requirements and it is good to go. You have low quality materials from suppliers. Many companies would do this. Well, I'm looking for a cheaper materials. So cheaper materials, cheaper supplier, worse raw materials, which eventually will come up with bad products. Inadequate training and poor or no work instructions. So people got hired and you just got pushed into the manufacturing or production line. They don't know really how to do things. They don't know how to carry out the job. They were not trained. They were not provided with SOPs, standard operating procedures, that guides them through the process. So it is typical that they are not going to manage to do it how they should. So it's a big thing and a big issue, and this could be, and the causes for the defects can be any of these. Some tools have been developed in order to tackle the defect. So first one can be stop the line principle. So it is an easy, straightforward approach. If you saw something wrong, stop the line, stop production, fix the issue, and then start again. And this can happen using an e-stop or overline stop cables that you might have seen through your careers, depending on what you do. And you would see that there is always a stop or e-stop button at every stage of the process. And then you have the poka-yoke. So the poka-yoke is mistake proofing things. And the poka-yoke is a simple approach, but it is a very useful approach. A pure or a simple example of the poka-yoke is your mobile SIM card. So think about your SIM card. It's a rectangle, and it has a notch at the top. So think about if it was a square without a notch. So in this case, you will be able to insert your SIM card in your phone at any direction. It can be the right direction. Well, you have 4 directions now because it is a square. So you might get it, or you will get it correct once out of 4 times. 25% chance that you are going to get it right. But with this rectangular shape and the notch at the top, you will never be able to insert your SIM card in the wrong way at all. So that is the whole idea of mistake proofing. How can I make my products designed in a way that, well, that user is not or will not be able to do any mistakes because, well, they can't do any mistakes, like how it is with that SIM card example. You can't insert it the wrong way. You have to insert it the correct way every time. And that is the whole idea. How can you do and how can you design your products and the assembly of your products in a way that makes it mistake proof? Then you have the 5 why analysis. So the 5 why analysis is a straightforward approach that works based on the principle that, well, ask the question why 5 times, and you're going to get to the bottom of it. So giving you an example in here. So, well, you have a problem with your car, and the car won't start. So you ask yourself a question. Why didn't it start? Well, the battery is dead. First approach that anyone is going to do is going to just go and change the battery. But what got the battery drained in the first place? If you did change the battery and you didn't get to the bottom of it, well, it might run flat in 3-4 months again, where it should be lasting for 4 or 5 years. I had a battery that lasted 10 years before. So after a few months, it went flat again, or it died again. That's because you didn't go past this stage. Because the right approach is to ask yourself again why the battery died. And that's going to answer another question. Well, the alternator is not functioning. So the alternator is not working how it should, so you should be looking at the alternator. But now you're still at the second layer. You ask yourself why again the alternator is dead. It's dead because the belt has broken. Well, the alternator belt has been broken, so why has it been broken? Because it has been used beyond its lifetime, right? Why has it been used beyond its lifetime? And start to look into, well, because the car hasn't been serviced for a very long time. And this takes you to the bottom of things and takes you to the fact that, well, other things or other issues are going to come up actually soon, more than just the battery dying. So you need to maintain your car periodically because you are going to start to get more issues than just the battery. And you're going to fix the battery issue as well. So the 5 why approach is an approach that guides you through how can you eliminate a fault from its sources. And it is extremely useful and beneficial whenever you are trying to get to the bottom of different things or different issues that might exist. It takes us to the question, is 99% good enough or not? Sometimes, or lots of you might say, yeah, 99%, I'm happy to take this at any day. But to start to think about, well, in the UK, well, you have 1 billion prescriptions written every year from the doctors. So what if you are working based on 99% quality? Well, 99% quality, that is going to give you about, what, 1 million or over 1 million wrong prescriptions a year? And that's quite a long or quite a big number to deal with because, well, all of these are wrong medications for wrong people. So that's a big thing or a big issue. The same thing with the Royal Mail, the Royal Mail, the postal service. You have 14.4 billion letters handled by the Royal Mail in 1718. So if you're working based on 99%, this means that you are going to have 14 million lost letters every year. So sometimes you can't really work based on 99% efficiency, and you have to be within the 100, like how we can see or how we've seen with these couple of examples. So it is really important to know what you are working with and what is the industry you are working at and what is the acceptable percentage of quality that you have to deal with. Moving on, we are looking at the waste of inventory. So the waste of inventory means that, well, I have a big warehouse and I have lots of different products, raw materials, half semi-finished products, everything in the mix. And it is just waiting there for them to be processed, sold, used, etc. So it can be excess raw materials, it can be work in progress, so semi-finished products, finished products waiting to be sold, different supplies, different spare parts that you might be dealing with. But when you start to look into the inventory, this is a dead money. This is a waste because all of these different materials, products, work in process, parts, etc., all of these are assets that are sitting there, they are losing value, and you have to keep them within safe, correct environment until you use them. And when you think about it, think about, for example, mobile phones or laptops manufacturing. So within the mobile phones, you have a new model every year. So if you made million phone of whatever the model that you have, and then you keep them in the warehouse. So first of all, well, you have to keep that warehouse safe. You have to control the surrounding environment. So from dirt, from water, from humidity, from whatever can happen across, from rats, for example. So you have to really maintain that warehouse in a correct way. And that is costly. So you have a running cost of maintaining and keeping these products safe and sound and up to the standards. What happens if you couldn't manage to sell these million phones within the year that you have? You start to look into, well, I have to come up with a new model, or other companies are going to come up with better products. And instead of me selling my phone for £1,000, for example, now I have to reduce the price. I have to sell it for 600, 500 pounds. So I'm losing on my product a lot in order to just make some of my money back or recover some of my money back and move on. That's a big thing. And one of the biggest examples that you can see as a waste of inventory, you can see it in the clothes sale at the end of the year. So towards the end of the year, all the shops are making all these big sales. And some shops are not making any sales at all. You start to think why this is making a lot of or advertising for sales and some others are not. And that's because that first one made the wrong assumptions and the wrong forecasting, and they made a lot of that product and they couldn't sell it within the year, and they have to make new line of products for the next year, and they have to get rid of the current one. So they put it on sale just to get rid of it and empty their warehouses. You will find this with everything. Every product that can go on sale, that's because they just have excess of it. They have a lot of it. They couldn't manage to sell, and they don't want to keep it in the warehouses for the following year or for whatever the duration would be, and they just want to get it out. The ones that don't go or do not make any sales or promote for any sales, these are the ones that made the right assumption, the right forecasting. They were working based on a pull system, not a push system. I'm not going to get into this, but they were super accurate and super efficient with what they do, that they managed to sell everything before the year ends, and now they don't have any spares or anything that they want to get rid of, and they are moving on with their lives. So they made the most of the profit on their products. As well, all of this inventory is a dead waste or a dead money, or it's frozen cash. So all of that money that you have for materials, for products, for parts, all of that money, you could have used it in many other things. You could have used it in the promotions for your products. You could have used it to develop a new product, to improve how things can work for you. But instead, you just have lots of different products and materials, etc., that are just sat down in your warehouse, not going anywhere. So inventory is one of the big wastes. What can be the cost of inventory? So holding costs, like how we said, to keep it safe and to keep it secured. Obsolescence, it's losing value all the time. Price erosions, the prices in general for any products go down over time. And opportunity cost, that, well, you just frozen all that money in one thing or in one in the inventory, in materials or whatever, and you couldn't really do anything else, which you could have done if you didn't make all of these products and wasted all that money on products and kept them in a warehouse. Lots of people would do this, and the justification for that, they would say, well, the raw materials are much cheaper when I'm buying in bulks. Yeah, but you are not looking into how that holding cost is going to impact you. It is going to increase it, and you are facing all these obsolescence, price erosion, the opportunity costs in the way. So it is very important to just buy and get what you want. What could be the causes of the inventory wastes? So making extra parts to cover defects and scrap. You know that you are, if you are supposed to make 1,000 parts, and you know that you have a 10% of defects, so you are making 1,100 just in order, or maybe 1,110 now, just in order to cover the defected products or the scrap that you have to endure. Employees are rewarded based on the output capacity, not regardless of the customer demand. So people working in the factory, they just get the incentives and they get the extras based on how much they're making, not on how much the customers are demanding and how much is getting sold. Unleveled production schedule. So different processes within the manufacturing environment or the processes are not leveled, and eventually it will impact the whole idea of having accurate processing time. Then you have the wrong forecast. So you didn't forecast properly. You thought that you are going to sell 1,000, but you actually sold 500. So you have extra 500 dead that you can't really get rid of unless you put them on sale or find a way to deal with them. Another type of waste is the waste of processing or over-processing. When we think about waste of processing or over-processing, this means that, well, we are using too much power, too much resources in order to make simple tasks. Think about, for example, instead of you having a car to go from A to B, you have a bus. So you have that very long 50-passenger bus to just take you to work. It is over-processing. You're having lots of different resources that can take you from one place to another. You could have bought a bike, for example, and that's going to be enough for you. Even having a car, it's a lot because you have all that extra space that is never filled up, but you are using all of the gas, all the tires, all the resources in order to go from A to B, when you could have just used a bike, for example, or a motorbike. So that is over-processing. Within the manufacturing industry, you can see that with buying larger equipment that have capacity way more than what the company is manufacturing or producing. I came across a company before that it was from the chemicals sector or chemical manufacturing sector. So what they had big blenders and big processing units that had much higher capacity than what the company is actually producing. And they had that issue that, well, our cost is very high and we don't know what to do with this. And the first answer, or the first thing that was suggested, well, get rid of these big machines that are using lots of energy that are taking a lot of resources to clean up and to get ready for the next batch, taking a lot of resources to maintain and keep them running, and get ones that are much smaller and enough for your operations. This is going to just cut your costs dramatically. And that is the idea of over-processing. You are using too much resources on tasks that do not require these resources. And that's just because, yeah, well, let's get a bigger one. Why are you getting a bigger one or more powerful one? Why you're having a 8 liters V12 car where when you can have 1 liter, 1.6 liters car that takes you from A to B? That is the whole idea of over-processing. Examples can be machines are slower or faster than needed, equipment that uses more energy than needed, some applications like how it is with drilling instead of punching. So how can you choose the best or the better, more cost-saving, time-saving application for your process? Extra critical checks when it is unnecessary. So you're having all of these different quality control checks between stages. You are so anxious about quality, etc., but you just started to overdo it. So what is the good number? What is the correct right number of processes that I should be following? Cleaning the same space more than once with higher frequency than needed. So again, just overdoing everything. Instead of just doing one thing or doing it the correct amount of time using the correct equipments and tools, you're just overdoing everything. Overdoing it is not going to save you anything, rather than it is going to cost you a lot. It happens with maintenance. You are over-maintaining the machines. So every day you're doing this big list of checks on your machines before production. Well, this wastes time out of production, so the machine is off until you finish all of these checks. You're overusing or using a lot of the experienced maintenance engineers' resources and time in order to do all of these unnecessary applications. So what is important and what should you do, and what are the frequency that you should be doing it? Instead of doing it every day, maybe once a week is going to be enough. And that is going to be back to different analysis and different criteria that we are not going to get into, because that's a really a big wormhole if we start to talk about it. So when we look at the cost of over-processing, so extra materials are used, excess space are used, cost of energy, extra time spent on extra processes, which in general, reducing over-processing increases productivity. Reduce all of these over-processing, all these different extra steps and equipment's use, and etc., and you will find your productivity increasing. Then we move into the cost or the waste of waiting. So the waste of waiting, it's all about waiting for anything, waiting for materials to come in, waiting for instructions to come across, waiting for the previous process to complete in order for you to start the process. So it is all about idling. You are just waiting and waiting for whatever it is that's not good, because you're still getting paid, you as an employee, and you're still you as a company are having all the costs. So you're still paying rent, you're still paying bills, you're still paying taxes, all of these different things. All of that is constant, is happening all the time. So when you're just waiting, doing nothing, that is a waste. And how can you reduce that waste? It is all about how can you perfect this application? How can you manage that everything that might be a reason or a source of waste and improve it? It's often replaced by overproduction or busy work, which could cause more harm than good. And mainly, the waste of waiting happens because of poor planning. It is not because of anything other than that, well, you didn't plan this well, you didn't construct your production line and the flow of information correctly, and you started to get this problem. So what could be the cost of it? Capacity loss, because, well, lots of the time you've been just waiting. So you're not making the 1,000 parts that you should be making every day, rather than you made 600. So capacity loss, loss in operating costs, or increment in operating cost, overtime costs, because you have to catch up with what you should be doing, loss of flexibility to meet customers' demand because you're just so tight up in order to catch up with what you should be making, what you should be doing. You don't have time and the flexibility to do the amendments or the changes that your customers might want. And this is going to impact your customers' relations. And then the cost of overproduction. So you started to overproduce things and you started to have that issue where nothing is planned, nothing is accurate, and you are just running in circles trying to meet or to make ends meet and to come to the end of the day to barely just meet what you should be doing. Moving on, you have the waste of motion. So the waste of motion, it is all about, well, I'm moving from one place to another, trying to get information from A to B to Z and move materials, move documents, move information, move orders, whatever it is. So any movements of people that doesn't add any values, this is a waste. By closely studying the motion and the time it takes in order to go or to get materials, resources from A to B, you usually or you can improve your operations time by 30 to 50%. And that's just by improving how everything is laid out, how the whole process is constructed. We are not again going to get into what are these different tools and what are the optimized or the different manufacturing setups and environments that suits every applications, everything that you might be making, doing, producing, service that you have, etc. But there are many different ways and structures and approaches that are there that can help you and support you as a manufacturer to reduce that motion as much as possible. So in general, when you reduce the waste of motion, it contributes to the overall reduction of the change or the waste in time. Examples can be walking. So you're walking from one place to another, reaching for tools and supply. Think about that. You might have a toolbox, and that toolbox you have all of these different tools, and everything is messy and everything on top of each other. So again, that is a waste. Searching for items, lifting parts and materials, choosing between parts, rearranging certain areas or certain section of the factory or the setup that you have. All of that is waste, and it takes a lot of time, and it wastes a lot of time as well. Different reasons for the waste of motion. So mainly can be due to poorly designed process. So you just built a process or a manufacturing process without any science behind it. You didn't follow any efficient setup. So again, it created that issue. And that poorly designed process can be due to obsolescence. So you might have started small as a company. This company started smaller 20 years ago. And they started to expand year after year, and they add a section here, add a section there, add a smaller storage area here, add a small process there. So you started to expand year over year, which is a good thing because you are making profit, you're doing good, but you started to have that messy production system. So everything is everywhere. And this causes this issue of motion that nothing is next to where it should be. Nothing is lined up how it should be. And you start to look into how can I overhaul the whole thing. You have lack of standard workplace. You're not following anything or any specific standards in your documentations, in your tool arrangements, in your warehouse, and the placement of different things. As I said, the poor work area layout and design and disorganization of everything. You're just throwing things, whatever it can be. And in general, you can say that the waste of motion is the mother of all productivity wastes. Some tools can be used in order to reduce the waste of motion, something like 5S, for example. So just a housekeeping process, rearrangements, organization, etc. You can look into the workflow analysis, spaghetti diagram, which I believe a lot of you might be familiar with. So you're just looking into, well, if you have a sheet, a diagram that shows you where everything is, the different area sections, and you start to follow up. Well, I'm starting from here, and this is my end point, for example, here. So what do I have to do in order to make one product? So I have to go here, and then I have to go back there, and then I have to go down here, and then I have to go to the scrap bin, and then I have to go to whatever, the decoiler, stamping, I'm just doing whatever. So you start to find that, well, this is a messy pathway. It's not efficient, it's not good. I have to redesign this process to make a better flow. At certain points, certain cases, you can't really do this because of the nature of what you're doing. For example, like how it is with the hospital. So you can't really rearrange it to the perfect setup, like how it is with with automotive manufacturing, for example. Rather than you have to accept how it is and you have to make it as less impacting as possible. But again, this is back to totally different topics and totally different areas of discussion to find out what are these different types of manufacturing setups and natures. Then you have the waste of transportation. So waste of transportation, waste of movements. Moving parts, moving information, moving end products, moving raw materials between places. You have big warehouses, you have different sections. You are moving all of these different places and all of these information, materials, whatever it is, between places. Moving between sites, for example, like fulfillment centers for Amazon. Why are they in certain places? Why are they in, I don't know, maybe you've noticed, well, there is an Amazon warehouse wherever you are or next to where you live. So why is it there? This is not a random selection for just any place to be placed at. It has been selected properly. It has been selected due to certain demands and certain geographical allocations, etc. Something like the point of gravities or the center of gravity allocation, etc. Many different tools as well are there to determine what is the best location for anything that you might have, whether it is inside your manufacturing facility, or where do you even place your manufacturing facility in the region. So that waste of transportation is a big thing, and it is an impacting thing because it can cost you a lot as well. In the moving, you are moving different parts and equipment, so you need resources. It is wasting time, it is wasting transport, it is wasting motion, etc. So all of this can accumulate on top of each other. So again, some examples is moving finished goods to storage, moving work and process to the next step, moving between areas, moving parts between the line, working papers, working paperworks around the office, moving items to quality assurance, etc. So it can be many things that are requiring transportations. And how can you, for example, modernize it? So instead of using pen and paper anymore, use something digital. So again, all of these different solutions, whether it is rearrangements, whether it is relocation, whether it is using different pieces of technologies, etc., all of this can tackle the waste of transportation. So instead of using the mail to send a letter, send an email. Instead of taking 2-3 days now, it's just going to take a minute. So that's the whole idea, really. How can you transport information, materials, etc., efficiently and quickly? And you have to see that how impacting and how good that is when you look at Amazon. Amazon just excelled in the transportation and moving of different parts and components. And that's why they can deliver within the same day or next day. And they are the ones that invented this. Before Amazon, everything was delivered within 3 days. Normally, 2 to 3 days, that was the normal thing. And then Amazon came with same day or next day delivery. And this is exactly what made Amazon what they are and what got the people to go to Amazon instead of continuing with eBay, for example, that was there. So this is one of the things you start to look into, little things, but they are the core principle that made the success of many companies. So what could be the causes of the transportation? Outdated as well, plant layout, large batch sizes, overproduction, inventory costs, and you have big warehouses, transfer of materials, paperwork, etc. All of this can be causes of it. So waste of overproduction, which as well is called waste, the mother of all wastes. So it occurs when you are making more products than what the customers need. So as I said earlier, you start to feel that, well, all the different wastes are linked together, or some of them are linked together one way or another. So that's why they were called the 7 deadly wastes, because one way or another, some wastes are linked to each other. And when you tackle one, you start to need to have to tackle the other one, etc. So again, the waste of overproduction, it can be reflected by that example I gave you, by this mobile phone production where you made a lot, you couldn't manage to sell it. Now you have to put a sale on it, or like how it is with the sales that you find with all the shops towards the end of the year, and they are trying to, or the end of the season, and just trying to get rid of the products as quick as possible with any money. Even if they lost on it, it is still better than keeping it in the warehouses and moving it back and forth and sell it again, and new models are going to come up, etc. So that's a big headache that all the companies don't want to go through. So this is going to mark the end of today's session. I hope that was useful. I hope that gave you a good idea about lean and manufacturing. You start to think that, well, you can start to use different technologies. And again, can be for a different topics for a different time, but technology can support with the reduction of these different wastes, whether it is by monitoring, by control, by modernizing and using IT systems, etc. All of this can help, and you can start to relate your industrial automation, for example, or you start to include your electrical backgrounds or whatever you do as tools that can tackle these wastes and can improve your productivity, efficiency, performance, etc. So yeah, I hope that was useful. I hope that was insightful somehow, gave you some good indications, some good ideas of what manufacturing sites can be suffering from and what makes a company more profitable than the others. You are living in a competitive environment. You're living between many companies that are making the exact same thing. It's not only one company that is making computers or one company that are making tables or paint or whatever it is. It's many companies that are making the same thing, and they are competing to get the customers that are buying the exact same thing. So you are competing with quality, you are competing with price, you are competing with customer service, etc. All of these are things that can be improved by addressing all of these different sources of wastes. And based on this, you start to have that competition and you start to win against your competitors. So yeah, I hope that was useful. Thank you for today. Thank you for attending and listening for this. I hope that was a little bit insightful for you. And now I'm just going to hand it back to Como to wrap it up.
Thank you so much, Dr. Shaalan. That was very informative. I'm sure our attendees can agree to that. And I'd like to take this moment as well to thank our attendees for joining us. We know you could be doing something else, but you're here with us. So we do appreciate that. And I would just like to turn your attention to our upcoming courses. So currently for our higher education courses, we are running 2 bachelors and 2 masters. So for our bachelors, we've got one in industrial automation and one in electrical engineering. And for our master's program, we've got power system analysis and renewable integration, as well as the industrial automation and instrumentation control. So we also do have short courses, and we currently running a promotion for our professional certificates of competency, which are delivered through our well-established EIT sister institute. So normally the course is around £933, but if you apply before the end of November, the promotion that I've just included in the chat box will be applied. So, secondly, I'd also just like to turn your attention to our certificate of attendance. So please make sure you fill out the form that is on the QR code or on the link, depending on which one you use. I've just included the link as well on the chat. So this form will be available for 48 hours, sorry, for 48 hours. And after that, it will expire. So please make sure you provide us with the correct information so you are able to receive your certificate of attendance as well as the slides and the copy of the recording. So lastly, I would just like to inform you that we do have quite a few webinars scheduled for the remainder of the year. So if you'd like to attend any of them, I have included the link right there. So you can always go and register for anyone that meets your interest. And I would like to thank you once again for all attending our presentation today. If there are no questions, well, we'll give it about 2 minutes. And if there are no questions, we'll wrap it up and call it a day. Thank you all once again for attending our webinar today. So, Dr. Shaalan, we'll just give it 2 minutes. And if there are
Yeah, sure.
no,
No problem at all.
yeah, we can just wrap it up. So let me just go back there. So whoever hasn't taken the link can just scan with their phone so long. Okay, I don't think we are having any questions. There's no one typing in the chat box, nor are they typing in the Q&A function. So I guess we can call it a day. Thank you so much, Dr. Shaalan, and thank you so much to our attendees. Till the next webinar. Cheers.
Cheers. Thank you. Bye.
Bye.